Welcome to the session Multi-modal LLM data processing with Apache Beam. I'm Konstantin Buschmeier. This talk was created in collaboration also with Jasper, who is here, as well as Iris, who contributed greatly to the implementation of the actual code. Then, as you can see on my t-shirt, I'm from ML6. We all are actually. ML6 is a machine learning services company, and we help our clients build machine learning and nowadays, of course, also AI applications using technologies such as Apache Beam. Now, if we look at the title of the talk again, we see a couple of things. And today I will be motivating this using a use case. So we will see large language models. We see a variant of multimodal variant of this one. We will see how they can be used in data processing. And of course, we will also see how we can include Apache Beam in all of this. Now, the use case that I want to talk about today is as follows. So imagine a company that is in the business of producing and selling all kinds of building materials. So we are talking here, for example, about doors, about window frames, about roof tiles, about tools, but also about smaller things like nails and screws. And produce these products, but we also sell them. And of course, we are a modern company. We have an online shop, so people can just go there and buy all the things there. But not all of our clients actually use the online shop because they are experts, they are contractors, they know exactly what they want. They have a lot of domain knowledge, but they don't use the online shop because they would rather just send quickly an email in between jobs of saying, hey, I need these products by this date. Can you give me a quote from this? So for this use case, we basically start with customer requests for different products with different specification, and we want to end up with offering them a response with the generated offer. For this, we need to process in some way these customer requests. We need to extract the products. We need to see if we can find these products in our product catalog, and then we can create this request. If we have extracted these products, we need to do some kind of searching on our product catalog to see which products fit best. Now, the use case is a little bit more complicated because, as I said, these customers, they are really loose cannons. They send us everything. So it's not that we only get emails with a nice list line by line of one product, but they might send us forms, they might send us documents, they might send us images or sketches with dimensions, they might send us tables with products. Anything basically goes. And here's a couple of examples to motivate this a bit further. So for example, on the top left, you can see, okay, this is a very short email. We see some preamble, some niceties, and then just line by line, these products are the ones that I want to order. We have the same basically in 3 longer paragraphs. So we also need to extract the same products from this. And as it's emails, we also have, of course, not only plain text, but also, for example, HTML. But it gets worse because maybe these clients also send us documents. So they type something up, then we have a lot more stuff that we need to extract and also different formats. So here on the left-hand side, you might see, for example, a Word document or some other kind of document. On the right-hand side, we see the same. We also have a table, and these tables pose another interesting challenge, I think, because they are somewhat structured. But if we want to process them, we, for example, also might only have the text. So we need to make sense of this and actually identify which field from the table actually refers to which row and which column. Now, this wasn't bad enough, so it gets worse. So actually, they might also send us, for example, these kinds of requests for quotes. So they just have like pieces of paper where they note down handwritten, these are the products that I want to buy. And in these forms, anything goes. So for example, at the bottom, we see this is not a product that they want to offer, but rather they include additional information of saying, okay, can you deliver all of these things by Monday? Or it can be that the information that is additionally included somewhere on this document is not for all of the products that they want to order, but rather just for a part. So for example, here we have a couple of window frames and the patio door that they want to order. And they say, hey, I would like to have all of these products in oak, but the door can also be in aluminum. And that's something that we then also need to decode and process to say like, okay, which part of which information actually belongs together. Now, if we look at this, we have customer requests, but it's really an inconsistent structure that they send us, right? And we have seen here that it's even worse because it's not only inconsistent structure, but also various formats. So talking about text, tables, HTML, PDFs, maybe images, so on and so forth. Now, taking a step back, what this basically is that we want to extract structured data for some search operation on our database from unstructured documents in various formats. And if we look at it in this way, we can identify a couple of challenges. So the first one is, okay, we have some multi-step operations, so we need to orchestrate this workflow. The second challenge is that we have a mismatch between the customer product descriptions and the product catalog, because as I said, these people are domain experts. They know exactly what they are talking about, but they will not use the exact same phrasing as is present in our product catalog. So we also need to bridge this gap. In particular, I'm talking here, for example, about abbreviations, which is or synonyms, and we don't want to manage this necessarily as a big list and keep this updated, but rather we want to process it in some other way. Then the third challenge is that there's no fixed structure, so unstructured data and various file formats. Now, how can we solve these challenges? The first one, okay, maybe that one is obvious. Orchestrate a workflow, Apache Beam, pretty nice to do it in this way. For the second one, we can use LLMs because they have some kind of intrinsic knowledge. And also, if we talk, for example, in this use case about building materials and products, the training data will likely have already included something like this. So they have some intrinsic knowledge also about this particular domain. So no particular fine-tuning is necessary. And then, of course, also through prompting by providing, for example, additional information. And then for the third challenge, we want to use multimodal LLMs because, for example, here we saw a lot of documents. We need to process these documents. And if we look at multimodal LLMs, they provide usually state-of-the-art performance, outperforming other models that we have used before for document processing, like Layout LM or something like this. Now, if we look at the use case again, okay, we have these two operations, at least some kind of processing, then it's in a consistent format, which is also augmented. And then we have the second step, which is this searching operation. And we want to do both of these with Beam. And then we have the first one we want to replace basically by some kind of LLM, and in this case, a multimodal variant thereof. Now, actually, if we look at this again, there's Beam and multimodal. So maybe there's a fourth challenge that we want to call LLMs from the Beam pipeline. And it's not really a challenge, so we can do this in at least one way, which is the RunInference. But today I will pose that there might be another way by using the enrichment transformation. Now let's talk about multimodal LLMs. And let's start by language models in general. So in 2017, there was a big breakthrough, let's say, with the introduction of the transformer model. If we look at this, the performance was greatly increased. And if we look at the architecture thereof, there is some kind of tension mechanism. And then we have two building blocks with a lot of different layers. On the one hand, this encoder and the decoder output. The encoder takes in textual representation and produces some kind of intermediate representation that doesn't mean anything to the human anymore. And the decoder takes this intermediate representation and produces some kind of textual output again. Skip forward 1 or 2 years, then we had this dichotomy between large language models, which only use one of these two blocks. So we have the BERT family on the one hand, which uses just the encoder block and growing in size of this. This kind of model is very good for classification tasks, but the downside is that we actually need to fine-tune it to be very task-specific. And on the other hand, we have the GPT variant, which is very good for generation and uses the decoder block. And we can also see, it's maybe too small here on this slide, but on the right-hand side, we see there's not only GPT-1, but 2 and 3, and we see, okay, it always increases. And through this increase in layers, the performance for especially this generation was getting better and better, which leads us to large language models as we have them today, which are GPT-like. And we can define a couple of characteristics, or identify rather. So they are very large. They were pre-trained on a very large data set. And this is interesting because this is what we will be using to bridging this gap between, on the one hand, our customer description, and on the other hand, also the description of the products which are present in our data set or product catalog. They are, again, very good at generation. They have some intrinsic knowledge. They also allow us to write instructions and they will follow it, which brings us to prompting. And we have a couple of techniques that we can use to actually bridge this gap. So we have in-context learning, we have zero shot, one shot, few shot, things that we can include in the prompt. We also have this chain of thought. So we say, okay, don't do this task just, but also explain the thought process behind it. And with all of these techniques, we enable the model to perform even better. And also what we have seen this morning already. There's this agent thing happening right now, which is also very interesting by basically providing tools that the different models can use. And then if we talk about multi-agents, it's also that we provide them with different personas so that they can collaborate and work together to solve problems. And then on the other hand, we also want to have document processing. If it's just text, that works already quite well. If we look at what was necessary for document processing before, so we have, for example, OCR, we have information extraction, we have labeling, we have classification, we have named entity recognition, we have entity linking, and so on and so forth. And we also see here on the bottom left that we have this multimodality, right? So these GPT-like large language models now also are multimodal, which is very interesting and very good for our form understanding and especially also the layout understanding. Now, if we look at multimodal LLMs, how do they work? So basically, it's the same GPT-like family, but we include a couple more embeddings of different modalities. And this means that we need to have some modality-specific models. In this case, for example, for a vision task, we have some kind of convolutional neural network, which will generate us a representation of an image. Then we include this together with our textual representation, use the GPT-like model on top of it, and that one can reason and basically solve tasks. And if we look at this, we have multimodal LLMs, which are even larger. We can still use them because they follow instructions. And we can now use this as well for example, guided vision tasks. So we can say, okay, there's a document, there's an image of a document, but you don't need to make sense of all of these things that are in this document, but rather only this one part that I'm interested in. So for example, if we talk about order forms or something like this, could be, okay, just extract me the total of all of the different products. So to summarize, multimodal LLMs, state-of-the-art performance for document processing. We have this guided information extraction, and we still have this intrinsic domain knowledge, which is super powerful for bridging this gap between two different kinds of representations of the same thing. And there's a couple of other use cases where we could say this also applies. So for example, this could be part of just organizing document collections. I think every company has a lot of documents, maybe even still analog, which they not only want to digitize, but also make available in a structured way. We might have a moderation task where we also have textual representations as well as images or videos or something like this. And we want to take all of these modalities into account to make moderation decisions. We might also use the same or it's very similar processing workflow for retrieval augmented generation, ingestion pipelines, and so on and so forth. Now we have seen the multimodal LLMs, and let's now see how we can use these in Apache Beam. So for this, I translated the workflow that we had before into a Beam pipeline. We again start with the source, so which is emails. We know there's different things inside, different formats, different structures. So we want to do some kind of filtering to enable our pipeline to do, well, format as well as structure specific pre-processing steps. So for example, for my HTML document or HTML emails, I want to maybe convert them to Markdown because that's much easier for my LLM to process and requires fewer tokens. Then I can do, for example, the same thing for PDFs, where I say I have on the one hand PDFs which actually contain text. I want to extract this. And on the other hand, I might have PDFs which contain images. So I want to separate these two out such that I end up with at least two collections. On the one hand, textual ones, and on the other one, on the other hand, images. And then I want to use two extract product processing steps. One's on the textual representation and the other one on the images. From this, I get my separate products. Then I want to do an operation by looking these products up in some kind of database. And again, that can be classical SQL, but also some other vector database or something like this. Then lastly, I want to create my offer and send it to the customer as a reply. And you can see that here we have two operations, the extract products as well as the find in the catalog, which require some kind of API call. And for both of these, I will be using the enrichment transformation. And also let it be noted here that we have on the one hand these emails, but if I, for example, have an email that contains a PDF, it doesn't mean that all of the product descriptions will be just in the PDF. Maybe that is something, and then the customer might have included another piece of information that is just in the email. So I also need to bring these two things again together. So actually, this block in the middle with the product extraction doesn't need to be necessarily two different models, but can be one model that is just multimodal where I send different requests to. Now let's start simpler though with the find in catalog. To make it simple, For this, I use just BigQuery. So my product catalog is already in BigQuery. Might not be the very best database solution for this use case, but it enables me to just reuse the already existing BigQuery enrichment handler that I can then use as my enrichment transform. I just need to instantiate it by providing, for example, the project and some table name, some information about which columns I actually want to extract, as well as, okay, how can I identify the rows that I also want to extract. Then if I want to do the same for my LLM, this is less easy because I need to provide or create a custom large language model enrichment handler, which is based on the enrichment source handler. For this, I need to just define a couple of functions or methods. First one is just instantiation. Then I have an enter method, which just sets up the model. In this case, it's a multimodal Google Gemini model. Then I have the actual call, and this one is maybe the most interesting method here because I, on the one hand, take something from my input, which is Beam row. And in our case, this is already a pre-processed prompt, which includes two things. On the one hand, the instructions for the model that it needs to do. And on the other hand, of course, the information. So that can be, for example, the text as I have it already from the email, as well as the text, the image, or any other kind of modality. If I have this, I have the prompt. Then I just need to generate the content by querying my model. Then I get the response. I package this in some way. So for example, here I have my textual output from the response as well as some metadata, and that's what I return. Then I have one more method to destroy again the model, which is less interesting. And there's one at the very end, which we'll be referring to at the very end, that I can also enable caching for if I use enrichment transformations. Now, for my Beam pipeline, I want to instantiate actually two of these LLM enrichment handlers. And they look very identical, except for the last line. So the row key is twice a bit different. And this is actually the prompt that I have. On the one hand, I have one prompt, which is just take all of this information and extract something from it. And the second one is in a step later by saying, okay, now take these products that I already extracted or found in my product catalog, and then use these to formulate an answer that you can send back to the customer. And then if we bring all of these things together, we have a pipeline that is rather short. There's also some stuff missing, for example, with the answer generation at the very end. So basically, we load our customer request data. This is the emails. Then we compose a multi-modal prompt, which again means taking, on the one hand, instructions for the model, as well as then parts with my different modalities. Then I make the enrichment call using my custom handler. Then I have the products. I say parse something for my database request. And here we see already one deviation from what I said before, because I don't actually use BigQuery. But for making this work locally, I was just using some basic SQL database. But I make nonetheless, I make a query and I get the products back. And then if we look at the prompt that, for example, I include, especially in the first one for the extraction, there's a couple of things to highlight here. On the one hand, I give some context to my large language model. I say, hey, you are working in a construction materials and parts company. I tell the model what it needs to do, construct an SQL query, and also extract the relevant information. And I also say something like, please only include fields for my query that are, for example, present in my database, because if it extracts attributes that are not present, this doesn't help me for searching purposes. Then I say your answer should be formatted as follows, because that is helpful for me parsing the answers and then doing the follow-up steps. And then I say, okay, here is actually the content that you might want to consider from the customer email. And this is basically all the parts that we have. So again, we have this pipeline, which goes from having these emails, and at the end, we send something out. And we have two of these calls using the enrichment transformation, once to multimodal LLM, and the other one for a database. But both of them, in essence, are just API calls to some other resource, right? So let's look at a concrete example where we do this. So we already saw this handwritten form or request for quote before. Also in this variant with this information at the very end. And then we, for example, get from this pipeline back the following, with highlight a couple of interesting things maybe as well. It says, okay, there's two products which are just available, so I can create an offer for you right away. Then for the other one, I couldn't find exact, but I have two alternatives, which you might consider. And I'm happy to produce a quote for you for these two. It also says, hey, I have some more variants of these alternatives by saying, okay, I don't have it not only in oak, but there's also some other materials available. And then maybe in the very end, I want to include something like here's a pre-filled shopping cart so that you can actually check out and interact with this further. But that's not the only way to interact, of course, because I said these customers are very stubborn. So likely they would rather respond with an email again, and then I would need to process that further and maybe also take into account already the conversation history of saying the first email was this, originally what they wanted, this was my first offer, and so on and so forth. Now, we've seen multimodal LLMs in Beam, and definitely we have seen, I think, today already, and we'll probably throughout the conference see a couple more examples where we use RunInference for this. And there are some good reasons, of course, also for it. For example, you can use local models, but you can also use remote models, with the caveat that for the remote models, usually you need to write your custom model handler. But otherwise, if you have local models, there are some nice things like resource allocation can be out of the box, and also you have this batching operation. Now, if we look at LLMs and multimodal LLMs in particular, they are very large models. So oftentimes I don't even have the option to do batch operations. I say send a single request, I get a single response back. Batching almost is means something else, because oftentimes the model providers for LLMs, which offer batch pipelines or batch endpoints, that means more like do these requests whenever there's resources available, but it's less time critical. Now turning back to the enrichment transform, I have remote models because it's just an API call. I need to write my custom enrichment handler, but it's quite nice because it's based on the request response IO. And by having this relation, I get two things for free, client-side throttling, and on the other hand, retry and back off. And there's a last thing, which is also can be very nice because, I mean, LLM operations are very costly. So I can also get caching. That might not be the best use case for the one that I presented today, because probably every customer request will be quite different. So not sure if the caching works in that way. But if, for example, I want to not only have a streaming pipeline that is processing my request, but also analytic pipelines, which run in batch mode, this caching can be quite handy to just have analytic workflows. All right, to summarize, what have we seen today? A use case for a building material company, which processes different modalities, different formats, inconsistent structure in the customer request and answers with an offer. We have also then seen the translation from this use case to an Apache Beam pipeline. We have seen that LLMs take the context into account. They understand imprecise phrasing, abbreviations, synonyms, etc. We also have seen or know now that they have this domain knowledge intrinsic already. Then we have seen that multimodal LLMs are super good at document processing and especially also this guided information extraction. We have seen that Apache Beam enrichment pipeline is super great for data augmentation because it's just an LLM API call, and we saw already a couple of examples for databases, but today we have also seen that you can use it to integrate LLMs for multimodal variants thereof. And with this, thank you very much for your attention. By the way, ML6 is hiring, so if you're looking, check it out. Thanks.